Welcome to the DIY Honda Garage channel. The error code P0087 indicates that there is a problem with the fuel rail pressure being too low in the Honda Fit models from 2015 to 2020. This issue can originate from a variety of causes related to the fuel system, which could include the fuel pump, fuel rail pressure sensor, or even the wiring connections that affect fuel delivery. The fuel rail pressure sensor plays a critical role in ensuring that the engine receives the proper amount of fuel to maintain optimal performance. It is located on the fuel rail, usually at the top of the engine assembly. Before starting any troubleshooting, it is important to check for any common conditions that might trigger this code, such as running out of fuel or the presence of other Diagnostic Trouble Codes, DTCs. That could indicate more complex issues within the fuel system. The DTC P0087 signifies fuel rail pressure too low, an important indicator that the fuel brake pressure is insufficient for correct engine operation. The fuel rail pressure sensor is a vital component, assessing the pressure of the fuel within the rail. It sends real-time data to the Engine Control Module, ECM, to make necessary adjustments, ensuring efficient combustion and engine performance. Located on the fuel rail, generally found on the intake manifold or near the engine, the sensor's functionality is crucial for the engine's fuel metering systems. If this sensor fails or if there are underlying issues with the fuel supply, it may trigger this DTC and lead to suboptimal engine performance. Recognizing the role and location of this component is fundamental for effective troubleshooting. When diagnosing for DTC P0087, several potential causes should be considered. One primary issue is running out of fuel. If the vehicle's fuel tank is empty, the engine will stall and may trigger this code. Another possible cause includes a malfunction in the fuel rail pressure sensor itself. If it's not working correctly, it cannot provide accurate pressure readings. Fuel leaks may also lead to this code, which can happen in various locations along the fuel line from the tank to the engine. Additionally, if other related DTCs are present, such as those indicating injector issues or misfires, they should be addressed first, as they may contribute to an overall fuel delivery problem. Correct identification of these causes is essential for resolving the low-pressure condition effectively. The symptoms associated with DTC P0087 can severely impact vehicle performance. You may notice the engine stalling, especially during low fuel conditions or when accelerating. This can be a direct indication that the fuel rail is not receiving adequate pressure to keep the engine running. Additionally, poor acceleration may be experienced as the engine struggles to draw fuel effectively, leading to an overall lack of power. Rough idling can also occur when the engine is operating with insufficient fuel, causing fluctuations in engine RPM. Being aware of these symptoms can help in identifying the presence of DTC P0087 earlier and allow for quicker intervention to avoid further complications. The first step in troubleshooting DTC P0087 involves problem verification through the Honda Diagnostic System, HDS. Start by recording all freeze-frame data and the onboard snapshots, as this information will provide valuable insights into the vehicle's condition at the time the code was logged. Next, switch the vehicle to the on mode without starting the engine to prepare the system for testing. Clearing the DTC present in the system is a crucial move, as it resets the DTC state and allows you to observe any reoccurrence of the code after conducting further tests. After clearing, start the engine and hold the RPM at 3000 without any load until the radiator fan activates. This action is necessary to stress test the system under controlled conditions, thereby ensuring that any existing issue can be identified immediately. In the second troubleshooting step, A test drive is essential to observe the vehicle's performance in real time. During this drive, monitor key parameters that were recorded in the freeze frame data, such as engine speed, vehicle speed, manifold absolute pressure, MAP sensor readings, throttle position, TP sensor inputs, and others. This comprehensive list of data sources helps in actively diagnosing any discrepancies that might surface when the vehicle is in motion. After the test drive, utilize the HDS to check for any pending or confirmed DTCs. If DTC P0087 is once again indicated, the issue is confirmed and necessitates deeper investigation. Conversely, if P0087 is not present, the issue could be intermittent, suggesting the system might be currently functioning appropriately, but should still be diagnosed to ensure reliability, including checks of connections and critical components as necessary. In this troubleshooting stage, the focus shifts to checking the operation of the spill valve associated with the high-pressure fuel pump. Start the engine and let it idle to evaluate whether any noise or vibration is perceptible from the spill valve. The spill valve controls excess fuel returning to the tank. If it is not functioning, it could significantly affect pressure readings. Any noticeable sound or vibration confirms the high-pressure fuel pump is operating correctly, which is a good sign. However, if no noise is present, it indicates that the fuel pump may be defective and should be replaced to prevent further complications. The spill valve's functionality is critical, as it contributes to maintaining optimal fuel pressure, which is necessary for the vehicle's overall performance. The fourth step in troubleshooting DTC P0087 requires you to turn the vehicle to the off mode and remove the PGM FI main relay from the under-dash fuse relay box. By doing this, you can isolate the fuel system and check how it operates without the relay engaged. Start the engine and allow it to idle until it ultimately stalls. This will help determine if the fuel pressure regulator is functioning properly. After the stall, crank the engine a few times and use the HDS to evaluate the specified parameters related to fuel pressure. If the fuel pressure converted from the pressure sensor reads below the threshold of 1000 kPa, it suggests a malfunction in the fuel rail pressure sensor or potentially the fuel rail itself. This proactive assessment ensures you can take corrective measures based on empirical data rather than assumptions. In this step, reinstall the PGM FI main relay and restart the engine to perform a crucial assessment. Once the engine is running, hold it at 3000 RPM without load until the radiator fan activates again. After reaching this seated operation, check the fuel pressure parameters again. For vehicles with a manual transmission, MT, utilize the line graph setup mode on the HDS, which provides a visual comparison of fuel pressure values over time. Confirm whether the values from the fuel rail pressure sensor and the direct fuel injection system pressure readings are nearly identical. If they match closely, it indicates that the fuel rail pressure sensor is operational and functioning correctly. Conversely, if discrepancies are noted, replacing the fuel rail pressure sensor becomes necessary to alleviate the low pressure problem affecting the engine. The sixth step focuses on checking the low pressure side fuel pressure. An accurate measurement will allow you to determine if the current fuel pressure is within acceptable levels. If the fuel pressure readings are acceptable, you can conclude that the low pressure side of the system is functioning correctly, allowing you to move forward with further diagnosis or repairs. However, if the reading indicates insufficient pressure, it may necessitate the replacement of several key components, including the fuel pump, fuel pressure regulator, fuel filter, and potentially the fuel lines. This step is critical to resolving any low fuel pressure conditions that might be impacting engine performance and could lead to further engine issues if left unchecked. In the final step of troubleshooting for DTC P0087, the high-pressure fuel pump is addressed. First, remove the high-pressure pump from its mounting area for inspection. Pay close attention to the cam that drives the high-pressure fuel pump and the roller mechanism, as wear or damage to these components can lead to insufficient fuel pressure. If these parts appear damaged or excessively worn, replacing the high-pressure fuel pump is necessary to restore proper fuel delivery to the engine. Ensuring that this critical component is functioning optimally is paramount, as it plays a pivotal role in maintaining the required fuel pressure. Carefully evaluate the wear on each component, as failure to address this can lead to recurring low fuel pressure issues and invites bigger concerns with engine performance. After completing the troubleshooting steps for DTC P0087, a rigorous verification process is essential. Conduct final checks to ensure all repaired or replaced components are functioning correctly. This includes confirming that the fuel rail pressure sensor and high-pressure fuel pump are operating as intended, as they directly influence overall engine performance. Clear any diagnostic trouble codes using the HDS once you've ensured everything is in order, and then perform a road test to verify that the vehicle no longer exhibits symptoms associated with low fuel pressure. Confirming that the DTC does not reappear during this test drive ensures that the resolution implemented effectively addressed the root cause of the issue. A successful verification will give confidence that the vehicle is back to optimal working condition. Conducting preventive maintenance is crucial in avoiding the recurrence of DTC P0087 and ensuring your Honda Fit performs optimally over time. Regular checks of the fuel system, including visual inspections for leaks and performance assessments of the pump and injectors, can help catch potential issues before they escalate. Monitoring the quality of the fuel used is equally important. Using low quality or contaminated fuel can lead to failures in the fuel system. Additionally, regularly replacing the fuel filter can prevent debris from clogging the system, ultimately aiding in maintaining consistent fuel pressure. Keeping an eye on these preventive measures will help ensure a reliable driving experience and potentially extend the longevity of your vehicle's fuel system components. In conclusion, understanding the symptoms associated with DTC P0087, such as engine stalling and poor acceleration, is vital for identifying issues early. Taking a systematic approach to troubleshooting the problem, beginning with verification, followed by detailed checks of components like the fuel rail pressure sensor and high-pressure fuel pump, ensures a thorough diagnosis. Once effective measures have been taken to resolve the DTC, it's equally important to implement regular maintenance practices to prevent future occurrences. Keeping an eye on fuel quality, conducting routine system inspections, and being proactive about changes in vehicle performance will contribute significantly to overall reliability. As with any automotive diagnosis, addressing underlying issues while promoting routine care preserves the vehicle's health and ensures a safer driving experience. Please like and subscribe to the channel. See you next time.